Today's lesson deals with function operations and composition. And as you can see, these are the different operations that we're going to do. We're going to be adding, we're going to be subtracting functions, we're going to be multiplying functions, and we will also be dividing. And every time that we add, subtract, multiply, or divide, there is a new domain for the new function. And we're going to be talking about that. So for the first part of the lesson, we're going to talk about the operations in dealing with functions: sum, difference, product, and quotient. And then on the left, I'm going to go ahead and show you the graph. So for example 1, we're adding f of x, which is a quadratic, and we're also adding a square root function. We're adding a quadratic and a square root function. And so we have f of x plus g of x. So we have f plus g of x. Don't get intimidated. It just means that we're adding both functions. So we have x squared plus, because remember f is represented by x squared, g, and I'm going to use a different color so you can see the difference, is going to be the square root of x plus 1. So the new function that we've created is going to be function f. It's going to be function f and function g. So you have x squared plus the square root of x plus 1. So what I did is I went ahead and typed it into my TI-84 Plus calculator. I have the first function, what was f, x squared, and the second function, square root of x plus 1, and then I'm going to go ahead and press graph. Now this picture is shown right here. It's kind of magnified. So you notice that our starting point is -1, and then as we go to the right, the y value goes to infinity. So we're looking for the possible x values of this new function, which is f plus g. This is our new function, f plus g. So we know that it starts at -1, and we notice that it's going to continue to go to the right to infinity. Now the question is, do we include -1? And the answer to that is yes. If we look at the table, and I go to -1, we still get the y value, but when we get to -2, you get an error. So you do include -1, so that's a bracket, and then you go to infinity. So now for example 2, we have f minus g. So I'm going to write that down, f minus g, and that's correct, we are subtracting, of x. And we know that f of x is x squared. So what you're going to do is you're going to write x squared. Minus, now you will subtract function g, which is the square root of x plus 1. So I'm going to go ahead and show you next how to write that into the calculator. So now you notice that on the TI-84 calculator we have x squared minus the square root of x plus 1. Remember that we are subtracting the two functions f and g. So I'm going to go ahead and press graph. And you get the same picture that is here on the screen. Now we've got to figure out the domain. So we know once again it starts at -1 and it does go to infinity. Okay, so the question is, do we start at -1 to include -1? Because we know that it's going to be after -1, it's going to be part of the domain. The question is, will the domain include -1? And we're going to go back. We're going to go back to our table, second graph. And you notice at -2 we get an error, and -1 is 1, so we do include -1. So the bracket means to include -1 in the domain, and it goes to infinity. So the allowable x values are from -1 all the way to infinity. Remember, in one of our activities, I did explain that we can say we have an imaginary vertical line here, and that we can move it in this direction, and that's going to show you the allowable x values. You notice that I can't go into this direction because the graph starts here at this point. But if we move it to the right, we notice that the x values increase and they go to infinity. Therefore, the domain is going to include -1 and it goes to infinity. Now we're going to multiply these functions, and we do have f times g of x. So we know that f is going to be x squared, and we know that g is going to be the square root of x plus 1. So what we'll go into our calculator, we wanted to graph this. This is the way you would write it, x squared times the square root of x plus 1. So go ahead and get your calculator out, and let's go ahead and graph it using the TI-84 calculator. So we're going to go to the y equals, we're going to clear it. We're going to type in x squared times the square root of x plus 1. Okay, so I'll give you a second to catch up with me. So we have x squared times the square root of x plus 1, and it should look like our picture here that's shown right in front of you. So I'm going to go ahead and graph it. And if I zoom in, you notice you get the same type of picture. So now the question is, what's going to be our domain? So our domain, it looks like it's going to start at -1, and then it will continue to infinity. Okay, so now the question is it going to be bracket, or is it going to be parentheses? And let's go ahead and go to our table. You notice we get an error at -2, but at -1 it's 0, so we'll include -1. Once again, I've highlighted the possible domain values here on the x-axis. And if I were to use this vertical line and if I were to trace this function, of course it would go through all these points that are on the graph. And you notice I'm tracing all the possible x values, and it starts at -1 and it goes into infinity. And we also figured out that it does include -1. So this is the domain. So the picture, the color tells you what are the possible domains. You notice that if this is after -1, let's say -1.5, then it's not part of the domain. Quotient is another name for division, and you can see that f of x we're dividing by g of x, and here is g of x and here is f of x. So we have the quotient of x squared divided by square root of x plus 1. You notice that we have, it looks like it appears it starts at -1, the domain, and it goes all the way to infinity. We're going to have to check our table. So go ahead and go to your calculator and type in x squared divided by, and I'm going to use parentheses just so I can make sure that it's included there. So you have x square root of x plus 1. So you have that there. And there we go. So we have x squared divided by the square root of x plus 1. I'll give you a couple of seconds to write that on your calculator. Okay. Okay, so we're going to go ahead and graph it. And it sort of looks like the Nike symbol. So we have like a swoosh. And we notice that we have x negative 1. So I'm going to write, because I want to figure out the domain. It appears that we start at negative 1, and we do go to infinity just like the others. But we got to see our table to kind of investigate what's actually happening. So I'm going to go ahead and go to the table, second graph. And now you notice that at negative 1, there's an error. So we cannot include negative 1. By the way, this is called an asymptote. And it's a vertical asymptote. Okay? So the domain is going to include all numbers between negative 1 and infinity, but not including negative 1. Does anybody know why negative 1 is not included? I'll give you a hint. And I'll stop so we can discuss it. That's correct. Negative 1 will make this undefined. Remember that you cannot divide by 0. So the yellow indicates the area in which the graph is behaving. You know, it's increasing in that area. Now, anything outside the yellow area, it's not part of the domain. Including negative 1 is not part of the domain. Just like we said before, it's because it's going to make this undefined. Therefore, there's a vertical asymptote, and that asymptote is telling people that understand that negative 1 is going to make this function undefined. And so the domain is going to be all the numbers in between negative 1 and infinity. This next part, we're talking about composition. And I'm going to remind you, you were taught this in Algebra 2, that little circle means composition. And that means that it's a function within a function. In other words, the input is not a number, but it's an actual function. So the first one that we're going to work with is f of g of x. So you're going to go to g of x, and you're going to tell me what is the expression. Okay, it's square root of x. So that will be the input. So I'm going to write this again. So what is the input? The input is the actual expression g of x. In this case, it's square root of x. That's our input. We still need our output. So our output is going to be the square root of x squared minus 1. That is our output. So what's going to be the composition of f of g of x? It's actually the square root of x squared minus 1. Remember, the square root of x squared gives you x minus 1. And you notice that we start at negative 1, and there's a reason why, we start at 0, x equals 0. And there is a reason why we don't go to the left of 0. And we'll talk about it right now. I'm going to use Desmos to explain this, but I just want you to see the graph beforehand. We know that f of g of x is equal to x minus 1, and we're saying that the domain starts at negative 1. So I'm going to go ahead and take out Desmos. And you notice we have g of x, which is square root of x, which is this one, the red one. We have f of x equals x squared minus 1, which is this one. So what I'm going to do is I'm not going to select these two. And now we have our graph, f of g of x. But you notice that it starts at x equals 0. And you might be asking, why does it start there? You notice that if I put negative 1 here, it's undefined. Now the question is, why is it undefined? It's undefined because when x equals -1, you're unable to find the square root of -1. Because remember, g of -1 is the square root of -1. So therefore, the domain has to start at 0 to infinity. So what is a domain? The domain is actually 0 to infinity. Why? Because of this square root right here. Anything below 0, x equal -1, x equal -2, is going to be undefined, and I just showed it to you using decimals. -2, -1, anything below 0, it's going to be undefined. So our graph looks like that. So now we're going to evaluate these compositions. So you have f of x, g of x, and h of x. And you have this composition f of g of -3. So what is the first step? You got to evaluate it at g of -3. So you're going to use this function. So you have 3 times -3 gives you -9. Now -9 is going to go back into f. So you have f of -9, since that is what came out of g of -3. So what is f of -9? It's going to be 2 times -9 minus 1. 2 times -9 is -18 minus 1 is -19. So we have that f of g of -3 is equal to -19. So for example B, we have f, and what is the input? H of 7. So you have to first evaluate h of 7. And here h of 7 is in the h is going to be blue. So we have as our input 7 squared. Remember, 7 is the input, plus 1. 7 squared is 49 plus 1 gives you 50. Now 50 is going to go back into the outer function, which is f. So now you're going to have f of h of 7 is equal to f. What was the output of h of 7? It was 50. So now you're going to use function f, the green one, so you have 2 times the input. Well, the input is 50 minus 1, and we know that 2 times 50 gives you 100, minus 1 gives you 99. So what's going to be f of h of 7? F h of 7 will give you 99. For example C, we have g, and then we have h of 24. So now our input into h is 24. So I'm showing you the process. G of h of 24 equals, so what you're going to have to do is h of 24 equals 24 squared plus 1. 24 squared is 576 plus 1. So g of h of 24, or h of 24, is going to be 577. So now the input for h of 24 is going to be g of 577. So now what you're going to have to do is use function g, which says g of 577 is equal to 3 times 577. So we added 1 to 576 times 3. gives us 1,731. So what is the composition? G of H of 24 gives you 1,731. So once again, you gotta figure out, you have to evaluate the output for H of 24 because 24 is the input. 24 squared plus 1 gives you 577. Now that becomes the input of G. You multiply times 3, since that's the process for G, and you get 1,731. So now we're trying to figure out f of g of x. So we have f, and now the input will be the actual equation, which is 3 of x. So we have 3 of x, g of x equals 3 of x. So now you notice that f has the input of g of x, which is 3x. So f of 3x equals, and we're looking at f, 2 times the parentheses minus 1. 2 times the parentheses minus 1. So you're going to write 3x. 2 times 3x gives you 6x minus 1. So now we can conclude that f of g of x is equal to 6x minus 1. Now we want to figure out g of f of x. So now our input will be f of x. In this case, f of x is going to be 2x minus 1. It will be an expression. So now we got to figure out what is g of 2x minus 1. So you just input into g, so it's 3 parentheses 2x minus 1. Why do I say parentheses? Because it says here x. And so we're going to input 2x minus 1. So you have 6x minus 3. For the next one, we have f, and then we have a g of 2a. So let's figure out g of 2a. And we notice that the input, once again, is 2a, and that's going to take the place of x. So 3 times 2a gives you 6a. That will go in the place of g of 2a. So now what you got to find next is f of 6a. So we got to find f of 6a. We know that f is 2 times a value x minus 1. So we notice that the input is 6a. So 2 times 6a gives you 12a minus 1. So what can we conclude? F of g of 2a will give you 12a minus 1. Remember, you had to find g of 2a, which in this case was 6a. That became an input for f, and what came out was 12a minus 1. So now we're trying to find g of f of 2a. So we have to find first f of 2a, which is 2 times the input minus 1. You always want to think about the x as an input, and then you'll get it straight. So you're going to write 2a. So now you got to find the product. 2 times 2a is 4a minus 1. So now that's going to be the input for g. So it's 4a minus 1. That is the input for g. So you go to g. G is, the input is 4a minus 1. So you have 3 times 4a minus 1. So you get 3 times 4a gives you 12a minus 3. So what can we conclude? G of f of 2a is equal to 12a minus 3.